This is problem 6.96. It's on page 346. In order to obtain a better weight distribution over the four wheels of the pickup truck of problem 695, the previous one, a compensating hitch of the type shown is used to attach the trailer to the truck. The hitch consists of two bar springs, only one is shown in the figure, that fit into bearings inside a support rigidly attached to the truck. The springs are also connected by chains to the trailer frame, so there's two chains as well, and specifically designed hooks make it possible to place both chains in tension. Determine A, the tension required in each of the two chains if the additional load due to the trailer is to be evenly distributed over the four wheels of the truck, and B, what are the resulting reactions at each of the six wheels of the trailer truck combination. All right. I began by drawing a figure so I could wrap my head around this problem. It was a bit confusing at first. There's obviously support at A. There's the 2,400 pound load that's applied 2 feet in front of the rear wheels. There's a trailer hitch that goes out to point D, and the distance between that center of gravity in the trailer and point D is 9 feet in terms of horizontal distance. The truck bed and hitch and everything then are next. That's my best rendition of a truck. The rear wheels of the truck are 3 feet from point D, and there's of course a reaction, we'll call it B here and A here. Now instead of working it per wheel, actually C here. Instead of working it per wheel, I worked it just as the two wheels together, two front wheels together, two back wheels, two trailer wheels together, and so forth. The center of gravity of the truck is, well, it's 2,900 pounds, but it is located a further 5 feet from the rear wheels, and then the center line of the front wheels is 4 foot to the center of gravity of the truck. I started off with no trailer because I wanted to know how much force was applied to B and C, because then extra force is going to be applied to B and C, but it's going to be the same amount is applied to both. So I started off with this, some moments about point B, taking counterclockwise as positive. Remember the trailer's not here, so there's no load at D. So some moments about B, we can find C, so that's pretty easy. Negative 2,900 pounds, if I'm summing about B, this is going to be a negative moment, counterclockwise is positive, multiplied by its moment arm of 5 foot, plus C times 9 foot. That sum has to come out to 0. So it's easy to solve for C, and I'll just write it up here because we're going to need this information a little bit later. In fact, let me write it this way. I think I used C prime for the total. So there's going to be the original load, which comes from here, which is C plus some delta. Once I add on the trailer, there's going to be some extra. So let me just write it that way. So the truck alone provides C amount of force, and that was about 1,611.11 pounds. So there's going to be some additional load. Let me call that additional load delta. Summing forces in the vertical direction means that calculating B will be trivial once we know C, because there's the sum of forces in the vertical direction. B plus C, the original load, not including the delta, with the truck just by itself. B plus Z has to equal 2,900. So it's easy to calculate that B is just 2,900 less C. So whatever force the front wheels don't support, the back wheels have to support, of the truck's weight. And so that was 1,288.89. And then later on I'm going to add a delta once I add the trailer, right? Because we're going to add the same amount of extra load to both the front and rear wheel set by this mechanism that I'm not showing the details of. So that's what I started off with. Then I decided to move on to this free body diagram with the trailer. In that case, summing moments about point A is the direction I decided to go. And the 2,400 pound load causes a negative moment, so 2,400 pounds times 2-foot moment arm. Let me forgo the units. They would be pounds times feet, so foot-pounds of torque. So there's a negative moment due to the 2,400 pound load about A. There's also a positive load of, we call this B prime. This would be B. B prime is B plus delta. So there's going to be plus B prime times, well, let's see, 2 foot plus 9 is 11, plus 3 is 14. So 14 foot is the moment arm for B. I went ahead and went all the way to the front wheels. So C prime times, let's see, where were we? 14 plus 5 is 19, plus 4 is 23 feet. And I skipped over the load that the truck applies. I shouldn't do that necessarily. I just got excited and carried away and went with the wheels. So minus 2,900 pounds because it causes a negative moment. But its moment arm would be 23 feet less 4. So 23 less 4, well, that's just 19 feet. And this sum has to come out to 0. Now notice that really these are not two unknowns. This is 1288.89 plus delta, and C prime is 1611.11 plus delta. Notice we're adding the same amount of load due to the trailer to the 2 front wheels. So this equation, the only unknown is delta. You can solve for it. I won't go through the algebra. You should. Well, I'll tell you what, I'll give you some of the algebra. Basically, take these two numbers, add them together, move them to the other side, you get 59,900 foot-pounds equals all this on the other side. Well, notice there's some numbers times 14 and 16 and a number times 23. That's just a number altogether, and that number is 55,100 foot-pounds. And then all we have is 14 times delta plus 23 times delta. So basically 14 plus 23 times delta, that's 37 delta. Where I'm using delta as an unknown variable. So now if you solve for delta from this, you'll find that delta is about 129.73 pounds. So we're adding about 130 pounds to the front wheel set and the rear wheel set, roughly 65 pounds to each wheel. Okay? So I went ahead and calculated the total of B prime by adding 1288.89 plus delta, and I got 1418.62 pounds at B, and at C I got 1611 plus 11 or 0.11 plus delta of 129.73. I got 1740.84 pounds. Both these, of course, are pounds. Now with that, I can sum forces in the vertical direction, and that's just A plus B prime plus C prime minus 2,400 minus 2,900. That sum has to be 0. So from this I can calculate A. Notice that B prime and C prime are knowns, and A comes out to 2,140.54 pounds force. But that's not really the question. I know the load now at all of the wheels. And so they want to know, let's see, determine the tension in each of the 2 chains, and what is the resulting reactions at the 6 wheels? Well, take these reactions, divide them by 2, and that'll be the reaction per wheel. So I didn't bother doing that. Per wheel, we're looking at roughly, 1,070 pounds or so in the back of the trailer. The rear wheels of the truck, we're looking at a little over 700 pounds apiece. Front wheels of the truck, almost 600 pounds apiece. Not really surprised the engine's in the front of the truck, so that makes sense. So it weights the 2,900 pounds so far forward. Well, not terribly far forward, but somewhat. It's closer to the front wheels for sure. I guess the engine and transmission are there. Both are fairly heavy. So anyway, that's not what they wanted to know. There's something interesting going on here. We've got a mechanism. Let's zoom in on this. In fact, let's take a free body diagram of the trailer. Let me make it larger. Here's our 2,400 pound force. This is all separate. We know that the reaction at the wheel is 2140.54. That's at the two wheels. I forgot to update my figure, but I updated the equation, so I'll have to erase this and change. But anyway, that's okay. And this is still only 2 foot forward. Let's draw some detail over here, though. If this is point D, there's a force up at point, I'll just call that force D, and the chain's pulled down with a tension T. The detail they gave us is that these 2 points are 1.7 feet apart. And of course, point D is still 9 foot from the center of gravity. So the question is, how much tension's in the chain? Well, if we sum moments about point D, taking counterclockwise as positive, we should be able to calculate the tension in the chain. So we have the tension in the chain times 1.7 feet. That's the tension in the 2 chains together, right? So there's, positive moment from the tension, positive moment from the 2,400 pound center of gravity, and a negative moment from the reaction at the wheel. So plus 2,400 pounds times this moment arm of 9 feet minus 2140. Let me put it on the next line because I'm running out of space. Minus 2140.54 pounds times its moment arm of 9 plus 2 equals 11 feet equals 0. From this you can calculate the tension. In fact, that's what I did. I said the tension is equal to 2140.54 times 11 minus 2,400 times 9 all over 1.7. That gives me the tension. And so that tension came out to 1144.67 pounds. If I want the tension per chain, since there are 2 chains, half of that is 572.3 pounds. That's the tension in the chain. Now this is not accounting for any dynamic effects. If the truck starts going over bumps, this tension in the chain could go up extremely high. Not sure that this is such a great idea for helping to distribute the load from the trailer on the truck, but for this static situation, there's the load in each chain, about 570 pounds or so.